Hello students, welcome to the second lecture on LR parser. To continue with the last lecture, in the last lecture we describing there are three steps used to construct the SLR parser. First step is nothing but to create the canonical set of LR0 item. Second step is nothing but construct the SLR parsing table using the canonical set of LR0 item. So we already seen in the last lecture how to construct the canonical set of LR0 item and how to construct the SLR parsing table using the canonical set of LR0 item. To create the canonical set of LR0 item, we are going to use the closure and go to operation. Now the third step is nothing but parse the input string using the SLR parsing table. So in this video lecture we are going to see how to parse the input string using the SLR parsing table. So we are already going to use this particular grammar to construct the SLR parsing table. So now we are going to use the input string like a, b, p and dollar. Now we want to parse this input string using the SLR parser. If we successfully parse this input string using the SLR parser, then we say this particular string is generated from this particular grammar, or syntactical structure of this particular grammar is, or syntactical structure of this particular string is according to the grammar. For that purpose we are going to use a stack. So current top of the stack is nothing but a dollar. So my input string is nothing but ABB dollar. So that is nothing but my input buffer. Currently I am going to read a. My current top of the stack is nothing but dollar. So now on the top of the stack we want to push the first step of a first state of a canonical set of a LR0 item. So what is the first state of a canonical set of a LR0 item? That is nothing but an 0. So I am going to push the 0 on the top of the stack. I am going to show you a stack as a horizontally, but it is look like this. So the last top of the stack is nothing but dollar. Now I push in the first step of LR0 item is nothing but 0. Now the meaning is nothing but on a 0 I am going to apply the A, means on a 0 I am going to use A. What will be my operation? On a 0, whenever I am apply the A, the operation is nothing but shift the current input symbol and then 3. So what is my current input symbol? A. So I'm going to push, so that is nothing but action part. So I'm going to push the current input symbol A, current input symbol A, and then state number. So what is the state number here? 3. So I'm going to push 3. So it is nothing but look like $0A3. Now so a reading is completed. Now my read pointer is incremented because we already shifted the A into the top of the stack. Now my current input symbol is nothing but B and top of the stack is a 3. On a 3 I am going to read B. On a 3, whenever I am reading a B, what will be the operation? Yes, 4. Shift the current input symbol. So what is my current input symbol? B. That I will be shifting to the top of the stack, and the state number is 4. So I am going to push that. So shift is nothing but current input symbol B and state number 4. Okay, so it will be like this $0A3B4, $0A3B4, both are same now. So I'm already shifting the B into the top of the stack. So my input buffer remaining is a B dollar. So on a 4 I'm going to read a B. So on a 4, whenever I'm reading a B, the operation is nothing but R3. So R3 is nothing but reduce 3. So reducing operation is nothing but pop operation, and shift is nothing but push operation. So whenever there is a reduce operation, reduce 3, then what is the meaning of R3? R3 is nothing but reduce the production number 3. So the reduce operation used for the pop operation. So how many symbol we are going to pop? We require to use the we require to check how many symbol present on the right hand side of that particular production. How many symbols are present? There are only one symbol. Then you should pop the two symbol onto the top of the stack. Means I'm going to pop the 4 and B. So it will be look like, so I'm removing the 4 and B, and it will be look like $0A3, $0A3. I'm performing the reduce operation. Because of that my input read pointer is not increment. So whenever I'm performing this particular operation, means I encounter this B. Now I encounter this B. You should replace this B by the corresponding left hand side symbol. So whenever I am performing the reduce operation, apply after removing or after popping the corresponding symbol from the top of the stack, you should push the left side non-terminal onto the top of the stack. So I'm going to push the A onto the top of the stack. So it will be look like this onto the top of the stack. Now how I'm fulfilling this 6? So 6 is fulfilling nothing but find out what is the last symbol present before the top of the stack. So that is nothing but an 3. So you should check on a 3 whenever I apply the A, on a 3 whenever I apply the A, I'll be moved to the 6, so that I'm going to push into the top of the stack. So I'm going to repeat it again. So whenever I'm pop the symbols from the top of the stack, it will be look like this. So I'm performing the reduce operation. Push the left hand side symbol onto the top of the stack. I'm pushing the A, so it will be look like here A. It will be look like A. So current top of the stack is A. So and the current input symbol is nothing but B, but there is no such kind of operation. So for that purpose, I want to push the state number onto the top of the stack. So how I'm going to push that? You should find out what is the symbol present before this top of the stack. So what is the symbol present before the top of the stack? That is nothing but an 3. Then you should check what is the output whenever we apply the A on a 3. So on a 3, whenever we apply the A, I'll be moved to the 6. So because of that, we should push the 6 onto the top of the stack. So that is nothing but my A6. And what will be my input buffer? Input buffer is as it is. I'm going to read the B only, because on a reduce operation, you are not going to increment the read pointer. So top of the stack is a 6. On a 6, I am going to read a B. So on a 6, whenever I am going to read a B, what is my operation? Reduce 2. So reduce operation is used for the popping the sum of the symbol from the stack. So how many symbol I am going to pop? So R2 is nothing but reduce the production number 2. So how many symbols present in that particular production? In the right hand side there are two symbols are present, means we are going to pop the four symbol 1 2 3 4. If the right hand side present of the production one symbol, then you should pop the two symbol. If there are present two, then you should pop the four symbol from the top of the stack. If there are three, you should pop the six symbol. So currently there are two symbol present in the current production, that is R2. So I'm going to pop the four symbol 6A, 3 and A. So whenever I'm popping this four symbol, after popping this four symbol, you should push the left hand side variable. What is my left hand side variable? That is nothing but A. So my stack after performing this operation will be look like dollar dollar zero, and what is my top of the stack? I'm going to push the A. Okay. So now I want to push the state number. So how I'm going to push the state number? So you should find out uh, what is the symbol present before this top of the stack. That number is nothing but 0. So on a 0, whenever we apply the A, what will be the state number is present on a 0? On a 0, whenever I apply the A, I'll be moved to the 2. So I'll be push the 2 onto the top of the stack. So it will be performing like this. So I'll be pushing the A and 2. So I'll be pushing the A and 2, and I'm going to show you. So firstly B is reduces to the A, then this A and this A is reduces to the A. So this A, small a, and this capital A will be reducing to the A. So my current top of the stack will be the 2, and stack symbol is nothing but dollar zero A and 2, and my input buffer is as it is. I'm not incrementing the reading pointer because I'm applying the reduce operation. Now on a 2, whenever I apply the B, on a 2 apply the B, what is my operation? Shift 4. So shift 4 is nothing but shift the current input symbol and the state number. So current input symbol is nothing but B, and the state number is nothing but 4. So I'm performing that. Current input symbol is B and my state number is nothing but 4, so I'm pushing the 4. So there is a shift operation, because of that I increment the read pointer. So B is already pushed into the top of the stack. Currently I'm going to read a dollar. Okay, so on a 4 I'm going to read a dollar. So on a 4, whenever I'm going to read a dollar, so operation is nothing but reduce 3. So reduce 3 is nothing but pop the sum of the symbol from the top of the stack. How many symbol I'm going to pop? So you should check the corresponding production. Corresponding production is nothing R3, that is the third number production. So how many symbols are present? There are present only one symbol, so you should pop the two symbols. So I'm pop the 4 and B. So I'm pop the 4 and B. So when I pop the 4 and B, it will be remaining as a $0 A2. So it will be defining the reduce operation. So here, whenever I am popping the two symbol from the top of the stack, we should push the left hand side variable. So what is the left hand side variable present? A. So I am pushing the A here. After pushing the A, we should also push the state number. So what is the state number we push? So that you should find out what is the symbol present before the top of the stack. So that is nothing but 2 and a. So it will be like 2 and a. So on a 2, whenever we apply the on a 2, whenever we apply the a, it will be moved to the state number 5. So on the top of the stack, I'll be push the 5. So it will be defining as a and 5. Okay. So means I'm reduces b to the a. So means I'm reduces from the ABB to the A capital A B dollar, then I'm reducing A B dollar, then I'm going to reduce A and dollar. Okay, so what will be my top of what is my input buffer? Input buffer is dollar as it is, because I'm performing the reduce operation. Now on top of the stack present a 5 I'm applying the dollar, 5 I'm applying the dollar. What is the operation? Reduce operation. Okay, so reduce operation is nothing but which production I'm going to reduce? I'm going to reduce the production number 1. So what is the production number 1? Yes, derives A. How many symbols are present? There are present two symbols, means you should pop the fourth symbol from the top of the stack. So I'm pop the 5, A, 2, A. Fourth symbol I'm going to pop and push the left hand side variable. What is the left hand side variable present? Yes. I'm pushing the yes onto the top of the stack. So it will be look like dollar, and we defining the 0, and then we defining as a yes. Okay, so current top of the stack is yes. So we require to push the state number. So which state number we are going to push? You should find out what is the symbol present this before the top of the stack, that is nothing but an 0. So on a 0, you should apply the this particular yes. So on a 0, whenever we apply the yes, so on a 0, whenever we apply the yes, you should push the state number 1. So I'm going to push the state number like 1 onto the top of the stack. So it will be look like dollar 0 yes 1. So it will be like dollar 0 yes 1. So will be push defined dollar 0 yes 1. So A is reduces to the yes. So this A and this A is reduces to the yes. So what is my input buffer? Input buffer is nothing but dollar. So on a 1, whenever we apply the dollar, so on a 1, whenever we apply the dollar, I'll be directly move for the accept. Okay, so we are defining here how to parse a string using a parsing table. Parallelly, I am going to show you how to create a parse tree which is started from the input string. Okay, that is the bottom up way. So I'm starting from the ABB from the bottom, and then I'll be reached to the starting symbol. So because of that, we say this particular string is correctly generated from this particular grammar, or the syntactical structure of this particular grammar is according to the syntactical structure of this particular string is according to the grammar. Okay, thank you. We will stop.